So welcome everyone, my name is Ethan McGuigan and I'm just waiting for people to log in and I can see people joining. So I suppose what I'm going to do when I can see the participants numbers going up there, I'm going to get you all excited to see if I call out your school. And with me, traditionally, I might as well continue as I always do. I start off with the Monaghan schools. So Fáilte go léir ó Coláiste Oriel in Moynihan, agus tá muid also le Dalty at Our Lady Secondary School, Castleblaney in Monaghan, and also Castleblaney College. So there's my big shout out to County Monaghan, but also we're delighted to have Eureka Secondary School in Kells, Skibbereen Community School. And you know, I was delighted when I was looking at the schools list, I could see schools from Raphoe, from the top of Donegal right down to Neagle Rice Secondary School, Scariff Community College, Clean, County Kildare, Scolwara. We have St Clair's and Valley James Duff in County Cavan. Sorry, I was claiming County Cavan as Monaghan there. We have Scolwara in Carrick and Sure, Beaufort College, Navan, Mallow College of Further Education, Coláiste Ciarán in Leixlip, Coláiste Osagon in Stillorgan. We have Killorgan Intermediate School, Cahersiveen, County Kerry. We have lots and lots of schools. We have schools from Dundalk, St Vincent's, and also St Louis in Dundalk, Sandymount, Blessington, Skibbereen, Longford, Kilkenny, Donegal, Castleknock, Oatlands, Holy Child in Sallynoggin, St Mary's in Naas, and Dunboyne College of Further Education. So they're just some of the schools that we have. And indeed, if you change your name, your Zoom login details to include your school name, I'll be able to see it in more detail. My name is Ethan McGuigan, I work in the university, and this is primarily aimed at TY 5th and 6th year students. And as I indicated in the email, this will be recorded and I will send the link to all those schools who are registered. And at that, I'm going to hand over to Uni, who's going to give the brain and how it works and what we can do to make it work better. I suppose the latter is what I'm most interested in, what I can do to make my brain work better. So Uni is an assistant professor in neuropsychology at Maynooth University. He has a long experience both with research and clinical populations, especially individuals with brain injury and older adults with mental health issues and dementia. He is currently focused in finding the best way to evaluate cognition in people with a low literacy and how to use virtual reality, which is hugely interesting, and other technologies to evaluate cognitive problems. So Una, I'm going to hand over to you. I'm going to turn off my video. If students can ask questions, if you use that in the chat box, I'll be monitoring those, and we will be asking Unai those at the end. So I'm going to hand over to you, Unai, and best luck.
I'm also trying to learn Irish, so I hope I can do it better next time.
Oh, my.
So good morning, everybody. I'm going to talk about the brain, and I'm mainly going to talk about how the brain works and what you can do. So we are going to talk about what happens when the brain is not working properly, and we're also going to talk about those brain disease, and we also will talk about how we can make the brain work better, because not everything in the brain is out of control. So there are things that we may keep in, there's something we can do, there are things we have under control that can be useful to keep ourselves fit. So let's start first trying to learn a bit about the brain. So the brain is made up with a lot of brain cells called neurons, and we have hundreds of thousands of millions. They have as many neurons in our brains as stars in the galaxy. So just to give you an estimate number. So there's many hundreds of thousands of neurons in our brain. And if we put all the neurons, all those brain cells in a row, we will probably arrive from Earth to the moon. So to give you an estimate, how all of them, they are contained, they are folded, and they are contained in our brain. So we are talking about something quite big here. In terms of the brain is around 1.5 kilograms of weight. And it needs to be nurtured continuously. It needs blood and it needs oxygen to work continuously. Otherwise, we would enter into severe problems. So this is something that we need to keep in mind. We need to keep our brain healthy and nurtured. This picture here shows you a little bit of how brain cell, these neurons work like. So what you see on the left side, those dendrites, those are like branches. And those are the areas where the information enters into the neuron. The information that will have different shapes. They go through the neuron, they go through that tail that is called the axon, and they go to the terminal. So that they will release something that will go to the next neuron and on, and it will continue that way to transmit the impulse. So how is that impulse in our brain? Well, when the brain impulse, when the information is going through our brains, inside these neurons, the impulse is an electric impulse. So that means that we have electricity in our brains going through the dendrites to the entrance of the neurons to the exit. But when that electricity impulse arrives to the end of the neuron and wants to communicate with the next one, then there is a release of chemicals, of molecules. So that's a chemical process. So we have electricity going through the neuron, and then that neuron releases some chemical molecule that is captured by the next neuron, and on and on and on. And it continues like that with every single thing that happens in our brains. We use our brain to perceive the environment, to move, to think, to talk, to feel. So all those things, all that information that allows us to do all those things are transmitted in this precise way by electricity and by chemical responses in the brain. So this is quite a complex picture. And you see that these neurons in their tail, they have this kind of beans. They look these bean-shaped things that they have covering the tail. This is a protein. This is a substance called myelin. So maybe the name doesn't tell you much, but there are some diseases that we may know people having these diseases, that what happens in the brain is that people lose this protection, this myelin, this kind of capsules, they are lost. And when people have a problem with this myelin in their neurons, they have diseases that are called, that will sound familiar to you, for example, like multiple sclerosis. So that sclerosis implies that the neurons are losing this protection. This protection is used so the electric impulse can go better, so that the neurons can do their work, their job much better. So if we lose that protection, that would imply that that impulse will go slower and will be more inefficient. It will work worse, so it will make the whole machinery in our brains work slower. And this will necessarily cause a lot of problems. So how does it look like? I mean, I showed you the shape of a neuron, but how does the brain look like? So this is more or less how the brain will look like, okay? And the first thing we will see this kind of folds on the brain. So if we extend all these folds, so the brain is folded on itself. This is called the cortex. It's like the surface of the brain. And it's divided in different areas. So the main areas that we see on the brain is the ones that you have in the picture. The frontal lobe, that's the frontal part of the brain that is normally related to decision making, problem solving, planning your behaviors, making plans for the future. But it's also very much related to emotional control, to the control of your emotions. So if somebody, it's sometimes you feel like, oh, that you are not able to make proper decisions because you feel overwhelmed by your emotions, because you're sad or you're nervous or you're stressed. That's because the networks, the neurons in your brain that are responsible for decision making and the neurons in your brain that are responsible for your emotions, they are very close to each other. So they affect each other. So that's why sometimes we have problems to make decisions if we are under emotional pressure. That parietal lobe, that it's more related to the processing feelings and sensations of the body. Also, the frontal lobe is also related to movements of different parts of the body. So our voluntary movement, if we want, when I'm moving this hand or when I'm moving my arm, some areas in the frontal lobe are sending a signal to my arm and to my hand so it can move. The occipital lobe in the back, the occipital lobe in the back is more related to vision, to how we see, and or to all the information related to attention, related to vision. And the temporal lobe is related to language, is usually related to hearing, and it's also related to some extent to the recognition of objects and recognition of faces. So, and you may wonder, well, how we know all that? How can we know that those areas are responsible of those functions, of those behaviors? Well, because we know a lot of how the brain works by studying people that have brain injuries and that have lesions or that have dementia. So much of what we know about the brain is because there has been a lot of studies about people who have problems in their brains because of a disease, because of an accident, or because of a different kind of a stroke or different kind of brain injuries. So this also gives you an idea of how the brain works. So if you will see this weird picture of this man with the big mouth and tongue and the big hand, this is a representation of how our different parts of the body are represented in the brain. Okay, so you don't have the same, so your hands and your mouth and your tongue, they can move more, they have more complex movements, and they are more sensitive than other parts of your body, that, for example, the trunk or some parts of your back or your leg. So that in this strange human that you see in the picture is just a representation to show you, it's just a picture to show you that we have many neurons, many nerves in our hands and in our mouth and in our tongue. So some of the areas are overrepresented in the brain because they need to make more complex movements, and we need to have more sensations in those parts of the body compared to other parts, like, for example, the legs or the trunk. And the same with movements. In terms of movements, the movement of our trunk is less complex than, for example, our fingers. We need different movements for our fingers, so we need separate neurons to move each of our fingers. Okay, so that's why what this picture is trying to show you. So, like I was saying, what happens when the brain is not working properly? What happens if we have a stroke? What happens with, well, remember that electric and chemical processes that I was talking before about the neurons, how those neurons need to communicate properly? Well, the brain could behave like the cars in a traffic jam. So if the traffic goes well, the cars just hold, so there's no accident, everything goes in a fluent way. But if there's an accident, then there is a jam and there's no way to pass. So the same happens in the brain. If we have an injury, the impulse, it won't go through the next neuron, so that will create a lot of problems. So this is one of the first brains that was studied properly in history. This brain is from 1895, and this was studied in Germany. And there was one neurologist that time called Broca that had a patient at that time with severe problems to speak. So the patient could understand the doctor, but couldn't express himself. He couldn't talk. And when the brain was analyzed after the patient died, they noticed that there was this huge injury in the left side, on the left side of the brain. So the conclusion was that that part of the brain must be related to language, to our ability to speak. And this was called the Broca's area in honor to that neurologist. And this has been studied for lots and lots of years. And it has been associated to speaking, to language expression, not to understanding the language. So this person could understand, but couldn't speak or communicate properly. So this is also what happens when you have a lesion in the temporal lobe, okay, in this part of the brain. You may not recognize objects properly. So if somebody asks you to just make simple copies of those things, like letters or shapes, these are the type of drawings you could make because you don't perceive them properly. Your eyes are fine. So this is something that you need to understand. The eyes are fine, but there's an injury in the brain that is not allowing you to create the mental picture of what you're seeing. Even if your eyes don't have an injury, your brain does. So you may have visual problems even if your eyes are fine. So this is an example of that. This is also something, a very curious condition that you may find in some people having a stroke. So some people normally having a stroke in the right part of the brain, they may have problems to see and to be aware of part of the space. So let's think of something. When you're trying to move your left hand, that left hand is controlled by the right part of the brain. When you're trying to move the right side of your body, you're controlled by the left side of the brain. So that implies that the left part of the brain is controlling the right side of the body, and the right side of the brain is controlling the left part of the body. All those neurons are crossing through the middle of the brain, okay? So a lot of years ago, when there was no medication for epilepsy, for seizures, the doctors didn't know what to do. So people were having convulsions, seizure attacks, and the only surgery that was at the time was to cut those neurons connecting the left and the right hemisphere. So the seizures stopped, but people had a lot of problems to coordinate and to move because they couldn't communicate, the left hemisphere couldn't communicate properly with the right hemisphere. So this is something also that we learned by studying people with injuries. Also, one of the things that might happen if you have an injury on the right side, you may have this condition that you see in the picture, that you can be completely unaware of the left side of the space. So that implies that you don't see and you don't hear and you don't notice everything that is on the half side of the space. So if people having this condition, when you ask them to copy a drawing, they may ignore the left side of the picture. They may just copy the half right side of the house, the half right side of the clock or of the flower. Even when you ask them to save themselves, they may save only half of the face or eat half of the food. So this is a serious condition that is raised because of this type of injury. So this is something that can happen because of a stroke or other types of injury, just to show you some examples of what happens when the brain is not working properly. Another condition that some people may have is what is known as the inability to recognize faces. So you may perceive faces, you see the eyes, you see the nose, you see the bird or the glasses, but you don't recognize the person you have in front of you. This might happen because of an injury, but some people are born with this condition and they may not know it. So the feeling for these people is that they can recognize people by paying attention, for example, to the glasses or to other clues. But if they have to recognize a person and to distinguish between that person from others, they have severe problems to do that. So they may have the feeling that you may have now when you're looking at this picture, that you see the faces, you see the hair, but you don't recognize anybody in the picture. Okay, so this is also something that might happen when you have a brain injury. Also, this is the example of what I was telling you before about the multiple sclerosis, that this protection for the neurons is lost. So this is what might happen in certain diseases. And again, this is something that I don't know if you have anybody in your family or in your surroundings with having this, that they say, well, my grandpa or my grandma, they have dementia, so they have forgotten everything, or they have forgotten who I am, or they don't know who my mother is or who my father is. So this is a quite common condition in people when they get older. It's not clear why these things happen, but this picture what shows you is what happens to the brain of somebody with Alzheimer's disease. Normally what happens in these individuals is that they start losing their memory, and then they start losing everything else in their brains. So it might happen that they start losing their memory and start not recognizing others. Sometimes they recognize others, but they don't know, or they are familiar with that. So others they may seem familiar to them, but they don't have a clear idea of who they are. And sometimes things could go worse. Sometimes they see a person in their house that maybe is their husband or the wife, but they think they are imposters. So you're not my wife, or you're not. So this is very hard for the family. But this is something that might happen during the course of the Alzheimer's disease. It's called neurodegenerative, which implies that the brain is progressively decreasing, progressively declining. And there is a moment that the person is not being able to do anything anymore. So it starts with memory, then it may start with decision making, and then the whole of the brain is finally like with a lot of holes, so they lose a great part of the brain. But these conditions, multiple sclerosis, Alzheimer's, or these kind of problems because of a brain injury, I mean, they are not treatable, so you cannot reverse many of them. Okay, you can train people to live better, and this is something that neuropsychologists in collaboration with other disciplines can do, to do treatment with these people so they can manage better in their environments, they can manage better in their lives and live and have a better quality of life. But at the end, many of these conditions are not preventable. However, there are other types of harm that we can do to our brains that are preventable. And one good example of something that is preventable is the alcohol consumption, for example. Okay, so here you have a picture of two individuals who are the same age, 43 years old. But what you see on the left side is a normal brain with all the neurons. So all the white part, the clearer part that you see in the picture, all those axons connecting to each other. So what are we seeing in the right picture? That is, you may think, oh, why is it so black? You may think, is this because the neurons turn black, or is it because the neurons disappear? Well, the answer is the second. Those neurons disappear. They end up leaving a lot of holes and spaces in the brain. So that involves that what you're seeing here on the right side of the picture is the picture of somebody who is losing his brain, literally. The neurons are dying, and these holes in the brain, these black gaps that you see there, that means that once there were neurons there, and now there are not neurons there anymore. So that implies that the brain is not working properly. This is a brain of somebody with alcoholism, with chronic consumption, repeated consumption of alcohol over and over the years. Okay, and this is what happens to the brain if you consume alcohol in the long term. I call it this preventable because this is something that you can avoid. You don't necessarily need to become an alcoholic. You can control your life and say, okay, no, knowing what the brain is doing to my brain, knowing what the alcohol is doing to my brain, maybe, well, I take other decisions rather than this. So this is another example of a different drug. So this is an EEG, electroencephalogram. So this is the electric, and this is a measure of the electric activity of the brain. And you may wonder, but is this with alcohol or is this with Alzheimer's? Well, this is the activity of the brain of somebody after smoking weed, after smoking cannabis. Okay, so this is the brain before normal electric function, and this is the brain in chaos when somebody smokes weed, when somebody smokes marijuana. Okay, so the occasional consumption may not be a problem. There are even therapeutic applications for cannabis, for example, for pain and for cancer, and especially for side effects related to pain. But it has also been seen that the drugs like marijuana, they normally, the body takes a lot of time just to get rid of them. So with alcohol, people get drunk, and then after the hangover, okay, the day after, if they only drank once, they recover more or less. If they are chronic consumers, then they will have severe problems like the ones you saw here. With cannabis, it's the same. If you're a consumer for long periods of time, there will be a moment that cannabis in the solid state, so that's like the, these things that you put into the stew, like these vegetable pills that you throw, like the Knorr pills that you put in the food, in your stew or in your beans or whatever. So they have that shape. So imagine that substance, that solid thing, put in on the way of your neurons. So you have one neuron here, you have another neuron here, and they try to communicate with each other. And then you have in the middle of those neurons a substance that is causing a traffic jam in those neurons. So that implies that the neurons won't communicate properly, that people will start to feel that the brain is becoming slower, that they may not think with enough clarity, that they are increasingly having problems to think properly. Okay, and this is an effect, a long-term effect that has also been seen in cannabis consumption. Also, some people having this consumption for longer, they may have other additional problems. Okay, but this is, I wanted to show you how the brain, how we can study the brain, just studying the electric activity of the brain and how different substances may affect the brain. And this is also what happens in our brain activity when we don't sleep properly. Okay, so Alzheimer may not be preventable if you don't know that you're going to develop it, not yet. Hopefully the science is evolving a lot, and we are increasingly identifying the potential causes for Alzheimer and putting potential treatments that may delay the progress of the disease. But what happens when you don't sleep well? If you don't sleep well, why we sleep? So we sleep because our brain needs to restore during the night. Our brain needs to process all the information that has been during the day. So we sleep, and then our brain rests, and our brain processes all that information that is useful, and also takes the unuseful information and throws it to the trash, to the bin. Okay, but if we don't sleep properly, all that trash, all that junk that we have in the brain is not processed properly. So that means that the brain is not behaving in the way it should. And the more and more that we prevent ourselves from sleeping properly, if we don't sleep properly, there will be a moment that our brain will start behaving will suffer memory problems. We may have attention problems. We may not be able to respond properly. So we will notice that our brain is not what it used to be. And recent studies have also linked that people that chronically sleep poorly, that might be a risk to develop later Alzheimer's when they get older. So we have to take care about ourselves, not only drinking too much alcohol or smoking too much weed, but also sleeping properly. And just think that people in drugs or in alcohol, they also have problems, sleep problems. So everything is related, and all these things could be preventable. So apart from telling you what you should avoid, well, what can you do in a more positive way to improve how your brain works? Well, there are different ways, there are different things you can do in order to protect your brain. Well, there are different factors involved. You could be genetically, you could be in a better position because of your biology, your genes are better, and that implies that you won't develop. So you don't have any gene for Alzheimer's, that will mean that you will grow older and you won't have any problem. But some people have some genes related to dementia. So that sometimes is a question of good or bad luck. But there are other things that we can do. For example, education. It has been seen in many, many studies in psychology, neuropsychology, and neurology that people with higher levels of education, they get older in a better shape. And if they have a disposition to develop dementia when they get older, if they study and they have enough studies, that could imply that they live without dementia for longer. It could happen, it could even happen that their brain may be having Alzheimer's, but they may live without dementia, without showing symptoms for longer. So giving yourself a proper education, it's a good idea. Also, having a good occupation in your life. So if you have an occupation where you have to think a lot, make decisions, if you have an occupation that is very demanding in terms of using your brain, that is also a good option to keep your brain trained and healthy. Also, literacy, reading, being involved in cultural activities is also good to, has been seen, the research has seen that it's also good to protect your brain. physical activity, aerobic exercise, running, swimming, playing football, whatever that implies aerobic activity. It has been seen that this stimulates the production of oxygen and the blood circulation in the brain, and that improves the way our memory, our language, our attention works. So physical exercise through our whole lives is a very good option to keep our brains healthy. Good, then leisure activities, a good quality of life, not having too much stress. I know, well, not having anxiety or not having, well, this, having a good life, having good leisure activities, active leisure activities, or finding your time to relax, to say stop, to not to be stressed, is also good for the brain. The stress is very bad for the brain because it produces certain molecules or substances that make the brain work worse. So if you're stressed because you don't concentrate, that will cause you more problems to concentrate. So try to find your time to relax, to stop, to think, and say, okay, this is the best way to, I have to take care about myself and to have to take care about my brain. Also the food, we cannot live just eating kebabs and McDonald's. So we have to eat a little bit of everything. We need fruits, we need vegetables, we need what has been called the Mediterranean style of food. We need fish, we need vegetables, we need meat, we need all the kind of variety in our food, in our plates that we may have, because we need different molecules to have a proper nutrition, and this proper nutrition will help us keep our brains in a healthier way. Another thing that has been widely associated with having better brains when we get older is to be bilingual or multilingual, to speak and use more than one language. So you are in a privileged country for that, because you learn Irish and English. You're learning two languages since you're young. So that implies that puts you in a better position, not only to learn other languages, but also to train your brain. I come from the Basque Country area in Spain, so we were grown also with, I was raised also speaking Basque, which is very different from Spanish. So when you have to speak Basque, or when you speak Irish, or when you speak English, you have to make your brain concentrate in speaking that language. So it's like turning the lights on and off. You have to turn on the light for Irish and turn off the light for English in your brain. Okay, so this is how your brain works. You have to activate one language and try that the other language that you know, that they don't interfere. Otherwise, you will make a mixture. For example, if I start speaking Spanglish, a mixture of Spanish and English, that would imply that I'm not properly switching off the Spanish, okay, when I'm trying to speak English. So this continuous repetition of activating one language, deactivating the others, this seems to be a good training for our brains, and that will keep us healthier. So if you are bilingual or multilingual, yes, this is something good for your brain. It's also going to be something useful in order to learn new languages in the future, but don't think that just knowing English will be the option. So you can be open to learning other languages, and it will be very helpful for many reasons, in terms of culture, in terms of experience, but also in terms of protecting your brain. And then activities like puzzles, reading, video games. Video games have been proved that they have a significant positive impact in health. Okay, so for a lot of years, games, the only news we heard in the news were video games associated with violence, with aggression. But the truth is that when we are playing video games, even the violent ones, we are putting some of our cognitive abilities like decision making, orienting ourselves in the maps, in the space. So there are many cognitive abilities that we have that can be trained using video games. So video games can also be a good option. And if you're thinking of, well, of working in psychology, there are a lot of people that are psychologists working in video games companies in order to make these video games more engaging, and also to make video games more attractive and more useful for players. So this is an option for people thinking about psychology. So, and this links precisely with this idea. If you want to know more about the brain, what can you study? And what things that you have studied before are useful for you? Well, you can study medicine, you can study neurology, you can study neurosurgery, but you can study also neuroscience and focus on studying the molecules of the neurons of the brain. And you can study psychology, and more precisely, you can focus on neuropsychology. I'm a neuropsychologist, so that implies that I have learned about how the things that happen in our brain affect the way we behave. And this is what you will study if you study psychology and neuropsychology, how different things that happen to our brain affect us in our daily lives, affect the way we speak, the way we remember things, the way we relate to each other, okay? So these are the things that you can study to know more about the brain. Also, you will see a lot of times that we have statistics, we have ways to predict how a disease is going to evolve. So if somebody's getting Alzheimer's now, what are the expectations? So all these expectations and all these things that we saw in the images here, how we analyze all these things? We analyze these things using mathematics, using statistics. We use mathematics and statistics in order to predict how things are going to evolve, how many people in a country are going to develop dementia, how many people are going to be benefited by a particular treatment. For all those things, we need the maths. Okay? And all the science we have learned, all biology, knowing how cells work and how the brain works, you need biology, you need maths. All those things are important in order to know more about the brain. So these are things that you already know, and that you may say, okay, what do I need maths for? The maths are a headache for me. Well, the maths could be useful in our lives because everything, we are surrounded by maths in our lives, in our environments. And when it comes to study the brain, don't think that psychology or studying the brain is something strange. It's another, psychology is a science. And that implies that we need to understand it as a science. So we need biology, we need maths, and we need to learn all these things in order to be able to say how people will behave when something happens to the brain or when they react to some things in the outside. So there are many, it seems so, okay. So these are the things that could be useful for you if you want to study psychology. And these kind of things, it's also very cool stuff that you can be working on. So like Ita mentioned at the beginning of the talk, I have been involved with a lot of research using virtual reality and seeing how video games and video game-like technology can be useful in psychology. So there is a lot of involvement in technology when you want to study psychology. It could be psychology of different branches. So it doesn't necessarily need to be just neuropsychology, but video games, virtual reality, augmented reality, these kind of technologies are very present when we study psychology and when we do research to try to understand our brains better and the way we behave a little better. So if you think about psychology and dedicating your life to study psychology inside the brain, just think that you will be using very likely technologies like this. And so that's also an additional thing that you need to keep in mind, or using the iPads or using different kind of technologies and video games that are very widely used, because video games are not just for entertainment anymore. They can also have a very positive impact in our health. So in psychology, we use all the latest advances in technology in order to know more about human behavior. So what resources you have out there at a click, at the distance of a click, if you want to know more? Well, there are different different books. These are maybe for smaller, younger children, like Brain Lab for Kids, but these are experiments that can be done to explore things in neuroscience, a book of the brain and how it works. This is a board game called Cortex. This is good for every age, the Cortex Challenge game. So this is a very good and very entertaining game for up to 8 players. So there are a lot of board games, like I said, not only video games, but board games like Cortex can be very useful also to train your cognitive abilities and to train your brain and to keep your brain fit. There is this documentary in National Geographic in Disney Plus, which is Brain Games, that it will show you a lot of curious and very interesting events and facts about how the brain works. You have this webpage, Neuroscience for Kids, but if you don't consider yourself a kid anymore, you can go through this webpage, brainfacts.org, and you have a very cool 3D model of the brain. Okay, not this plastic thing that I have here, but a virtual 3D full model of the brain, so you can explore the brain and you can go area by area. You can click on different areas and it will tell you what those areas are doing in the brain, how it works. So if you want to know more, this is a very cool resource that you can use. And then you have also this Sharp Brains webpage where you have brain teasers, puzzles, and games for teens and adults. So this is what I wanted to show you today. I want to show you how the brain works, what happens when it doesn't work properly, how you can protect it, what's in your hands, what's in your control if you want to protect your brain, and what are the different cool things that you will study or that you can study if you want to know more about the brain. So I really hope that you enjoy this session, and please feel free to make any questions. I will try to answer as many as I can in these minutes. Otherwise, you can send me maybe an email and I can try to answer those in the near future.
Thanks a million, Una. That was so interesting. And we had a couple of messages there to say that students had to go back to class and they want the recording of it, just to let people know that there is the recording. It was really, really interesting. And especially when you were talking about, you know, I was feeling guilty about the sleep, and then I was feeling guilty about maybe I'm not eating a healthy enough diet. And then you said sport, and I was like, oh, I do a wee bit of sport. But I was just wondering, you know, I'm a huge Monaghan GAA fan, and, you know, we often get very disappointed. And I suppose there's Kerry schools on here today. And yes, Kerry beat us up in Inniskeen there a couple of weeks ago. How you hear a lot about sports psychology, and, you know, even in golf, but even in GAA, it's becoming more and more professional.
Yeah.
How can you tell us, and probably I didn't ask you this beforehand, so sorry if I'm springing this onto you, but can you tell me about the growth in sports psychology and why even psychology is hugely important in sports? And then there's another question here, so I'll get to that.
Well, the psychology is very important in sports because when you're talking, well, because obviously sport players are humans, and humans have motivations, they have different mental processes when they are playing. So they need to improve their attention, they need to focus, they need to be motivated, they need not to be distracted by other events. So imagine that when you're playing, you are distracted by your own problems, or if you imagine that you start having this kind of thoughts of, no, we're not going to win this game, we're going to lose. So even if you were playing well until that moment, then you start suddenly playing bad because you are feeling anxious of doing things wrong. So I've seen that a lot, for example, in Spanish football. There are many teams having increasingly psychologists in their teams, not only to motivate, but also to create this group mentality, to improve the cohesion, the group, the feeling of that they are a group, that there's not just the individual ability for somebody else. So psychology can do a lot in training people to behave as a group, to keep them motivated, to find the right ways to motivate them, to keep them focused. And there is also a role even for neuropsychology, because we were talking about decision making. So in games like that, like Geographic football or other sports, you have to make decisions, make fast decisions in order to win the matches. So you can also train people to make faster decisions. So there is a lot of room for improvement and for work of psychologists in the sport areas, in either creating this group culture, this group behavior, motivation. And on the a little bit more negative side, there is a lot of involvement in psychology when we study concussions.
Yeah, so that's really good for the players, Uni, and you know, I'll feed that back to the Monaghan management team. What would you say for a poor old supporter like me? How do I keep motivated to go to the games and keep my faith in the team? Or, you know, I suppose I'm making a joke of that, but I suppose that's a different angle. But it's when you were talking about the sports, and I was just really, really conscious of, you know, we've over 1,700 students here. Some of them are probably coming up to leaving Cert, possibly getting anxious. And again, I'm throwing this at you. I have planned none of these questions with you. It's just the more and the more you talk. How, you know, adapting what you were saying about the sports players and that team mentality, anyone who's coming up to leaving Cert and, you know, in a couple of months, you know, facing big exams, what's your advice from a psychologist point of view on how students can stay motivated or stay positive, or, you know, coming up to exams? What would you tell students?
For the exams, for the Leaving Cert exams, you mean?
Yeah, because every June, without fail, I have the Leaving Cert, you know, dream.
Well, I could suggest that they are very observant in which is the best time of the day to study. So sometimes when you're, so some people are more morning people, some people are like evening people, that sometimes it's a good idea to study. Some people find it better to study in the evenings and then go to sleep. So they let their brain rest and process all that information. And so it's a good option to rest, have enough sleep in order to avoid these memory problems. Remember, the brain that somebody not sleeping. So you need to sleep properly. You need to have good nutrition in those days, and even to do some physical activity, because the physical activity gives oxygen to our brains. That will make us learn better while we are trying to study. If you know that you study better in the mornings rather than in the evenings, try to get as much as you can of that moment of the day. And don't become obsessed with, no, I have to memorize this in the late evening. Maybe it's better just to go to sleep and wake up earlier, have a proper breakfast, and then study. You will make much more progress rather than trying to getting obsessed with studying in the wrong time for you. So it's good to know yourselves a bit better, which are your most efficient times. And please take care of yourselves in terms of eating properly and making exercise, because you need your brain to be working properly in those days. I know that anxiety in those days could be very difficult. So sometimes even just doing breathing, or there are simple breathing techniques in order to relax. Sometimes the best relaxation technique is distraction. So sometimes you just need to quit and try to distract with something else for a few minutes and then come back. So it will be very different for each individual how to approach this. But these are at least some of the things that we saw here are applicable for this. Just try to sleep enough, try to get enough sleep, eat properly, and then try to see which are the best moment of the day to approach the study. And don't study in the very last day, because sometimes what happens in the very last day, that's that we are studying with a lot of anxiety. And sometimes those last bits of reading before the exam, what can cause you is cause you anxiety. And when we have anxiety interfering with our attention, that implies that when we try to remember things, our brains are not fresh. We are putting some interference with, oh, this is not how I remember it, because you are not reading it properly because you're anxious. So when you do that in the very last day, in the very last moment, if you didn't study it properly before, that will cause you a lot of concern and doubt. So if you're anxious and if you're depressed or whatever, that will interfere with your memory, it will interfere with your attention, and it will interfere with your decision making. So study as much as you can, and the day before the exam, go to the cinema, go running, go and play sports.
Okay.
My best advice. I promise it works. I had something like that in this, like something like the Leaving Certificate in Spain when I finished my secondary. It was very similar. We had like 8 exams in 2 days. That was like a marathon. The day before the exam, actually the 2 or 3 days before the exam, a lot of us just went to cinema, just disconnect. What you haven't studied in the last 3 months, you won't study the morning before the exam. That's clear. Yeah. So make a plan, know yourself when to plan your timetable good, so you make the most of it, and care about take care about yourself. And then the main thing, you're not a number. So whatever happens in the Leaving Certificate, that's not you. That's an exam. Okay. I have my own opinion about this type of exams, and sometimes they could be very unfair, because it seems that we are leaving all our future to just one exam. Look, there's future after the Leaving Certificate, no matter what happens. So you're not what that exam is telling you. You're more than the one exam. Okay.
Oh, that's brilliant. Yeah, that's really. Yeah, I could relate to a lot of what you said, and pity I didn't talk to you 20 years ago, because I might have done better in my exams. But just on what you said, you know, the exams are just one part, and there's paths into most careers, you know, so I'll just say that, and I'm living proof of that myself. But Kalash to Oriel, and I'll let you finish on this one because we're over time, but Kalash to Oriel have asked a question. Yeah. Can the effects of mental illness such as depression, anxiety, etc. be seen on medical tests such as CT scans and EEGs?
Okay, the answer would be that sometimes you may see some some changes in the activity in the CT scans and the EEG, but it's very difficult to say that those changes are because of depression or because of the anxiety. So sometimes you may see changes, but you may not have a clear idea to what to attribute those changes. So those techniques, EEG, CT scans, neuroimaging, they can be useful, but they don't have the last word in what's going on in the brain. They are not a definite 100% diagnosis. In order to know more about depression and anxiety, sometimes even just the interview with the patient, seeing how they approach different problems, the kind of thoughts they have. So thoughts like, I'm a failure, I'm never going to be able to do this. Things like that kind of all or nothing thinking, those kind of thoughts are more symptomatic of depression than any brain scan. Or even when people report that they have memory problems, or they say, no, my memory is not what it used to be, and then you do a memory test and their memory is fine. It's like, okay, there's something going on that is not problem with memory. Maybe there's some emotional or mood problem that is making this person feel that they are not worthy, that they are worthless, that their brain is not working properly, something is going on, and there's no brain injury here. Maybe there's some mood disorder, depression, anxiety. So sometimes even just the first interview with the patient, talking to them and seeing how they approach different problems can tell you more than a CT scan, particularly with mood disorders. When we're talking about dementia or other brain diseases, we need these kind of techniques in order to collect more information, but not for mood disorders. It's not that clear for them.
Okay, thank you so much, Unai, and I hope that answers your question, Kalash, Oriel. Unai, a lot of messages there of thanks. Very, very informative session. Just to let schools know, this afternoon, hopefully I will have the link up and live, and I'll email you all it, so you're welcome to show it. And thank you, Unai, for agreeing to let us record it. You're welcome to show it in other classes and share with your colleagues also that might be of interest. Anyone can contact me. You all have my email address if you need any more information on this. We offer psychology at Maynooth University, and Unai would be one of the lecturers, but this was more a talk about showing your expertise, Unai, and I learned so much. So on behalf of all the schools, hopefully, and myself, I really, really want to thank you. It has been a pleasure to work with you on this. And it was really, really interesting, and thank you for all your time. And schools, don't hesitate to drop me an email, and I can forward on any questions you have to Unai if we haven't answered any of those today. And thank you all so much for your time, and Unai, we'll talk later. Thanks everyone. Bye bye.
Slán.
Slán.